The rational zeros theorem gives us a way to identify potential rational zeros of a polynomial function. This is the general definition of a polynomial, and this polynomial is degree n. We have a sub n, which is the leading coefficient, or the coefficient on the x to the nth term, and a sub 0 is the constant. As a reminder, a rational number is any number that can be written as a fraction. Here are a few examples. All of these numbers are rational. So if a polynomial function has a zero that is a rational number, that rational number must be of the form p over q, where p is a factor of a naught, which is the constant at the end, and q is some factor of the leading coefficient. Let's look at an example to better understand what this theorem gives us. Here we have a polynomial function, and when we're asked to find the zeros of a polynomial, it's helpful to be able to factor it. But some polynomials, like this one, don't factor using the grouping method, so we'd have to use something else to help us find the zeros. The list of potential rational zeros gives us a place to start looking for the zeros of this polynomial. So what we'll want to do is look for all the factors of p, and again p is the constant, and as well all the factors of q, which is the leading coefficient. So the factors of p start with 1. We could multiply 1 times 15 or -1 times -15, and all of those would be considered factors. So we do need to put a plus or a minus on the 1. The next factor of 15 is 3, and again we'll need a plus or minus for that one. The next factor of 15 that we get to is 5, and then finally we have the factor 15 itself, all of them getting a plus or minus. We do the same thing for q. The first factor of q is plus or minus 1. The next factor of q is plus or minus 2. Both plus and minus 3 are factors of 6, and plus and minus 6 are factors of 6. The list of potential rational zeros is going to be all possible combinations of writing a factor of p over a factor of q. In order to make sure we get all of them, we're going to need to stay organized. I like to start with the first factor of q and write all the factors of p over the first factor of q. So starting with 1 over 1 is going to be plus or minus 1. 3 over 1 is plus or minus 3. 5 over 1 we get plus or minus 5. And 15 over 1 we get plus or minus 15. Once we've completed everything over 1, let's move to all the factors of p over 2. So we have 1 over 2, which is plus or minus 1/2, 3 over 2, which is plus or minus 3/2, 5 over 2, which is plus or minus 5/2, and 15 over 2, which is plus or minus 15/2. Now that we've written all the factors of p over 2, we can move on to writing each factor of p over 3. 1 over 3 is plus or minus 1/3. 3 over 3 is plus or minus 1, but we already have that quantity in the list, so we do not need to repeat it. 5 over 3 is not yet in our list, so let's add that. And 15 over 3 is 5, which is in the list, so we don't need to duplicate that value. So we've written all the factors of p over 3, and now it's time to move to the last factor of q, which is 6. So we start with 1 over 6, which is not yet in our list. 3 over 6 is 1/2, and 1/2 is already in our list, so we don't need to duplicate that. 5 over 6 is something that we don't have yet, so we add plus or minus 5/6. And 15 over 6 reduces down to 5/2, which is in the list, so we don't need to write that one again. So now we have all the factors of p over 6, so this makes our complete list of potential rational zeros. This list gives us a place to start when we're looking for the zeros of a polynomial function.